So this part 2 of 11.5 is all practically visualizing what's happening between a graph and its derivative graph. Okay, if this can be a bit difficult to for it to soak in, you might need to find other ways to kind of picture what's going on. The first graph here is a line, quadratic, cubic, and then we've got a weird thing happening here. Now, does anyone know what this is called? Okay, you can see there's two lines happening in there. So we call this a hybrid, like a hybrid car, petrol and electricity, 2-in-1. There's a 2-in-1 here. This line is getting cut off here. This line can go all the way through, but it's stopping here. So we need restrictions on each graph. The other name for it, it's got time-wise, but piecewise. It's called piecewise. Did you do piecewise last year?
We didn't evaluate this.
Oh, do we do it this year? Okay, my memory's pretty bad. Okay. So remember, what does dy dx simply mean?
Gradient.
Gradient. So make a note if you want to be able to get into gradient mode, because this is the graph. This is a graph, but it's not. It's the gradient graph. Just try and put that in your head for a little bit. Looking at this line, what is the gradient of this line gate? What's the rise on run?
2 on 1, so it's just 2.
It's a 2 on 1. Okay, so therefore that triangle gives it away, but we can also pick up bigger triangles. And what would the ratio be between our vertical and our horizontal? 2 to 1 again. It's all 2 to 1 everywhere. So the gradient, no matter where you go along the x line, it's always going to be 2 to 1. Or 2 divided by 1 is 2. So it's like an ECG and someone's flatlined at 2. Okay? Gradient 2, but the measure of the gradient is 2, dead at 2. I'm just trying to make it stick in your head. Okay. Parabola. We're going from, we've got 2 parts of it. Well, we've got 3 parts of this gradient. There's a gradient. There's a few gradients here. From -1 onwards, Zaid, if I'm looking at this side, I'm going to put in green. If I put a ruler on that as a tangent, what's the gradient going to be? Is it positive? Is it negative? Or is it 0?
It's negative because it's going back.
It's negative, but not because it's going back. What do you mean by back?
Like going that
Oh, going that way.
Yeah.
Yeah, you're right. Okay, I get you. Okay. So therefore, from -1 onwards, we've got a negative gradient. Now, it kind of looks like this. Let's pick a point. Let's go with this point here, and which lines up with this point here. And then I'm going to put a cross here, and that cross lines up here. Think about it. The dot or the cross, which has the bigger negative gradient, Manny? Which one's steeper? The top one. And therefore, that cross is steeper on the gradient scale. See how it lines up here? It's more negative, it's lower. At this dot here, this is less steep because compared to this cross, the tangent, notice if I put a tangent over here, It's still negative, but it's getting flatter. Therefore, over here, it's still negative. It's still under the water, but it's slowly almost getting positive. Okay? Does that make sense to people? At which point is my next question, Perry, is the gradient 0? At -1, correct. For a parabola that is flat, look at the tangent, flat, but on its gradient graph, flat is what number? 0. That dot corresponds to there. It's on level 0. And then as we move forward beyond -1, Jesse, do we have a positive or negative gradient? Positive. We've got a positive. 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 Keep moving all the way down. Positive. It's all positive. Is that gradient getting more positive or less positive? Is it getting more bigger? Bigger, more bigger. More big or less big? More big. More big. So therefore, when I have our gradient function, this, we're going up an elevator, like at Greensboro Plaza or Shopping Town, gradient's going bigger, it's getting steeper. Okay, that's why. Can we notice something? A line becomes a flat line, a quadratic, when you derive, becomes a line. And then I could derive this line to get back to a flat, but that's a bit later on. You could do double derivatives if you want and just derive. That's more physics for those people. This one's a little bit tricky. Okay. Now, let's have a go. What's a good idea when we're drawing graphs? What's the main points that we want to kind of highlight before we start doing our graph? Let's look at this hill and valley. Okay.
Intercepts.
Intercepts. Good try, but it's not.
But what you're looking for is the top and bottom points of the.
I need more information.
Turning point.
Turning points. Good. Is that what you're trying to say?
Yeah.
Okay. Turning point 1. Turning point 2. Zach, what's specific about turning points? What's their gradients? 0. So over here, I must line it up wherever it meets. We know that that's going to be 0. Flat. This one here, yeah, it's a valley, but we must line it up wherever pretty much it is. It's going to cross the surface, the 0. Okay, next question. These help us to guide us. Nathan, from this point onwards, which is here and the red, is it negative or positive? Are you sure? If I put a ruler as tangents, I get a positive gradient. Okay, I get a positive gradient. So I'm going to do it this way. It looks like this. Okay, it's actually not a line, it's a curve. What do you think we're going to graph?
A parabola.
We're going to graph a parabola. Look carefully here. This middle section, from this turning point to that turning point. If I'm skating on the half pipe and I go down, okay, is it a positive gradient or a negative gradient? It's a negative gradient. And so what we have, this green is going to dip down. This bit here is the steepest point of the drop. So that lines up with this, if I can It's not to scale, forgive me. But let's say I'll just adjust it so that that's the steepest point, because that's as negative as you get as you're falling down. And then you're going to go down and land nicely. It's going to flatten out again, which looks like this. Cross lines up with that cross. It's the most negative down here because it's the steepest up here. And it creeps back to at 1, Nathan, what's our gradient? 0, which lines up with here because it's now on level 0 of our dy dx. And if he's got enough momentum, we start going back up. What type of gradient do we have, Emily, on that red section? Positive. And look how it's back up into the positive section, like so. Any questions with that? The last one today is our hybrid piecewise. This one in green, just looking at the dashes, what gradient, Maya, for that green section? What's the gradient?
1.
It's a 1. Because in my head, it's 3 by 3. 3 divided by 3 is a 1. So from 0 onwards, we have a gradient of 1. Flat lines. Okay. Looking carefully on this, let's color it in red. You might not be able to calculate it because of my drawing, but you can sort of see. Okay. What's that? It's a -3. It's greater than -3. That's the -3 gradient. Therefore, on the red section, we look down at -3 and we have, it's always -3 on that line, no matter how big the triangles you get or small. Okay. The last thing I need to express is this corner. Can anyone tell me at this corner, what is the gradient?
0.
It's not 0. Good try. Good answer. Okay. If you have a point sharing on both sides, the gradient coming down here is a 1. The gradient coming here is a -3. If they're different, you can't share the point. Undefined. Therefore, you must, on your gradient graph, put an empty circle because we can't define the gradient at that place where they meet. Hopefully that makes sense. If you understood it, well done, because it is a bit tricky to kind of get that in your head, what's really going on. Okay, any questions?